So, good evening, dear participants. Assuming myself audible, I welcome you all on session 5 of this comprehensive bioinformatics workshop, that is data science and machine learning for bioinformatics with Python and genome-wide association studies. So, we have with us today a very special guest, Satyanarayan Rao. Dr. Satyanarayan Rao, who is currently working as a postdoctoral fellow at Ramachandran Lab, University of Colorado, Denver. Prior to that, Dr. Satyanarayan Rao earned his post-graduation from prestigious Indian Institute of Information Technology and Management, Gwalior, MP, followed by a PhD in computational biology from University of South California, Los Angeles, California, United States. So Dr. Rao has into his credit a large number of fellowships, including Viterbi Fellowship for studying role of DNA methylation in protein DNA interaction, and a fellowship from Cancer League of Colorado for monitoring cancers using blood test. He has into his credit also awards like Professional Development Award for American Association Cancer Research Annual Meeting 2021. So, Dr. Satyanarayana Rao is also a practitioner of Kalaripayattu. So, his activities are diverse in nature. So we welcome sir on our platform, and with the belief that participants will enjoy with your experiences. Welcome sir, and now I am handing over session to yourself sir. Thank you.
Thanks a lot, Praveen. Thanks. Thanks for the kind introduction. Let me share the screen. So, all right. I hope everyone can see the screen okay.
Yes sir, your screen is visible and your voice is also perfect.
Cool. All right. So with the very nice kind of stage set by Avinash on variables and data types, now we are kind of leaping forward in like most widely used kind of data structure and other types that Python offers. And we'll start with most used data structures, for example, list, dictionary, and then we'll see how we can leverage on the kind of flexibility Python gives you. As you were told by Srinivas, Avinash, that we are moving in the direction that from this conventional legacy languages like C, C++, and Fortran, we are going towards the programming language where it's very easy. Like you want to focus on your problem rather than you want to focus more on syntax and everything like that. Like you have to say int a is equal to 5 or something. So you don't want to write int, you just want to say a equal to 5. So in that same theme, you actually also want to do more. You want to invest your time more on the research part or the thing that you want to do in a minimally coding way, right? So we'll take a glimpse of that today using list. I'll primarily focus on list today, and then we'll go into the dictionary in our next session. So I want to start with very basic example, like why do we need data structure and what is actually data structure, right? And so this is a very basic example. Let's say you have a kind of a class 2 student and you want to tell or make him learn, or him or her learn this name John Doe, right? So the way we basically do is we say letter by letter, right? And let's say you are developing an application where every time a single letter or character comes up, and the student learns in that way, right? So what comes naturally here is that order is important, right? You can't mess up, like you can't utter O first and then say J later, right? The order is important, and word by word, character by character moving is also important. At one letter at a time, right? So I want to highlight two data structures here, one good and one bad, because you have plenty of data structures, and it depends on the problem that you're working on. And based on that, you choose the data structure. Let's say if you choose a wrong data structure, you may end up in spending a lot of time in accessing the data, or even you will have loss of information, which I'll just explain here. So let's say you decided on choosing two type of data structure. One is called set. So as like very general definition of set is like you have elements in the set which are always occurring at only once, right? So if we say John Doe, you can see that the O is occurring twice, right? So we'll see how it is playing on in the programming language. So what we have defined here is a data structure DS of type set. We're just typing the variable in a way that it is convenient for you to kind of infer back. So what we did is in terms of learning process for the class 2 student is like we just wrote in this order, right? JOHN and then space and then DOE. As you already are aware now, these are character types, right? As we learned yesterday. And then I am defining another data structure called list. So you can see this important difference in these two structures. One is starting with curly braces, the set, and the other is actually starting with the square bracket. And again, the content is the same, right? But once we start printing the set, we see that the N, H, J, O, so you can see that the order is not preserved, right? But in the list, the order is preserved. So let's say if you have a prompt screen where every time you're going one by one and you're showing that flash of the character to the student. So J will occur first, O will occur later, second time, something like this, right? So what I wanted to convey here is that if you choose set as a data structure to make that kid learn, you are actually starting with a bad data structure. You are losing information on the characters, the composition of the name, as you're seeing the loss of one O here because of the set, and you are also losing the order in the set, right? So now I've given you the motivation that like data structure, choosing the right data structure is really important based on the problem. And now we will go into how we can use data list and kind of do many things, right? So the definition of list, as now we will practice also on our this particular prompt. But a couple of definitions first. So list is a data structure where you can store one or more data types, right? So things in the bold are something that I'll explain. So one or more data types together in an indexed format. So as I was just explaining, it has to go from first, second, third in that order. And they're mutable. Mutable as in that whatever the content you have at any or at any position and a given order, you can actually change it based on what you want, right? So here I'm having an example list, or we can actually start with a very simple example that you guys also can type. I hope for everyone the Jupyter notebook is open and it's all working fine. We can test it right away. Let's say we just say sample list is equal to, we can just say list of integers from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And I hope everybody can run this. You can, sorry, can I see the chat box, or let me see if
The chat box is in the middle, sir. Just left side of chat.
Wait, where is that?
So just move
That screen. Oh yeah, here. Okay, sorry. Oh yeah, cool. Sure. So I hope can any like one or two of you can say that you guys can run and everything is okay in terms of cool. All right. So now we have this sample list, and then what I said just in the definition is that you can store one or more data types together in an indexed format, right? And they are mutable, right? So before going into all this kind of let me put this one down here so that we can, yeah. So here we can say that so the order is there. So how do we access it, right? So first of all, we want to see what is the indexing, how like how can we access. So Python is a zero index based language, right? So everything starts with zero. For example, let's say you have this 2 element in a list, then the index of this element is 0 and the next element is 1, right? So the way to access this particular value at that particular index is calling like this sample list, and then if we say 0, then it is giving me 1 here, right? So let's say if we want to access the 5th element, then we say sample list 4. So that will give me 5, right? Because this is the 5th element, but the index is starting with 0, right? So we'll cover more on indexing because this is really important, and lists give you a lot of flexibility in terms of indexing. So let's say I want to access the last element of the list. I don't care how long the list is, but I want to get the last element. So we can say that sample list -1, right? So that gives me 10, right? So if I ask you to get the second last element, what will we use? Can anyone tell me? -2. Perfect. So let's go deeper, a little bit deeper into the list indexing, which will be fun here now. So the way Python has designed this indexing is there are 3 parameters. So let's say here you have sample list, right? Then there are 2 colons, so giving you this 3 kind of regions. Here is your start, okay, start, and here is where you put the end, till where you want to actually access the list. And then here is the step size, okay, right? Let me put this in a documentation mode, right? So what it is telling me is that you can traverse the list in a more user-friendly way, and you define how you want to actually access the list, right? So just giving you an example here. So let's say if I only want to get first 5 elements, okay, then what will I do? So I say first 5 elements. So the first always start with 0, right? And then the end is, if I want to get the first 5 elements, I say 0 to 5. Sorry, sample list, right? So, but here we need to think about it now here, that we didn't put step size. So the default value of the step size is always 1. If you don't mention it, it's 1 by definition. And indexing works in a closed and open interval kind of a fashion. So when you say 0 to 5, meaning that it started with 0, so 0, 1, 2, 3, 4. It didn't go to 5. So this is something we call in mathematics this closed and open interval, right? So this is denoted like this is closed and this is open, right? So it basically, when you say 0 to 5, means 0 to 5, we write it mathematically this way. And what it means is that it will traverse 0, 1, 2, 3, 4. It will not include 5. And this has many advantages when you're working, when you're programming. Let's say you have a data sets where you have observation for the time interval of like 1 hour, 2 hour, 3 hour to, let's say, 10 hour, right? But then you want to say what is the behavior before 5 hours and what is the behavior after 5 hours, right? So you want to say less than 5 and then greater than or equal to 5. So this particular slicing naturally gives you, so basically if you say, for example, let's just practice that thing here. If you say sample list, then 5 to if you just say 5 to nothing, then it'll give you everything, right? Because the second parameter is end, so by default it is end. So see, you are nicely separating the list in two parts: 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, right? But now you just used one variable like 5 as a parameter, that it giving me less than 5 and then greater than or equal to 5, right? So let's do some let's do one exercise. So you already have this sample list, but now we want to use this step size as a feature and get all the elements in the list that are at even positions. So how do we do that? So we have this sample list, right? So what are the numbers at even positions? Or let's say if we start with odd positions, then this is position 1 in like numeric kind of a normal real life scenario. This is position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So let's say if we want to extract all the even numbers from this list, so how do we start, or how do we actually slice this list based on these three values that are that we have in our hand? So what we will write, our first element has to be 2. So how should we start? Okay, Namrata said 1 colon colon 2. Okay, and then start with 1. So let's do let's say we start with 1. Okay, and then we want to go all the way to the end, right? But our step size is what? 2. So when we do this, then we are getting 2, 4, 6, 8, 10, right? Okay, somebody said 0, -1 and 1. Okay, this is a good point. So sample list, we'll practice this too: 0, -1 and 1, right? Okay, what happened? So what happened here is that you are going to the open interval. So this is a very good example that we all should learn here, that as Sandeep said, he said let's use this as a parameter, right? So when you say -1 at the end, right? So 0, -1. So let's practice just this part, and then we go to the step size. Okay, sample list. Why did we get till 9? Can anyone answer? Oh, okay. I'll explain that one also. 1:1:2. So -1 is last element, 1 before the end. Okay, last index is not included. Okay, right, because of the last value. So here, okay, so let's look at this. This, as I was just explaining, this is like open interval. Where is that documentation here? Here I was saying that this is like open interval, right? So when you said -1 here, then you're saying not to the full length of the list, but the last element, right? But it is going at, so you said 0 -1, right? So you are putting that last element at open interval, right? Index of the last element. So it will not be included. That's why it's going only till 9. It is not including the 10. If you hadn't put the -1, or if you put -2, then it will only go till 8. Does that make sense? Right? So these are really important features, or actually lessons that you should be aware of when you're kind of exploiting all these features, right? And somebody asked, please explain this :122, right? So again, we refer back to this documentation. So start index is 1. As you know, Python always uses the 0-based index. So the index of 1 is 0, index of 2 is 1, right? So we wanted to extract all the even numbers in this range. So that's why we started with 1, so that we point to this number 2, right? And then we want to go all the way to the end. See, the default of this particular parameter is end. So we didn't mention, I don't care what the length of the list is. I always want to go to the end. So I didn't put anything here. And then our step size is 2, because we know that we know this characteristic of the list, that it has number from 1 to 10. So we definitely know that when we hop on one, when we exclude 1 in this order, then we'll get to the next even number. So 2, and then skip 3, 4, then 5, skip 5, then 6, right? Does that answer your question, Shamita? Cool. So now, now can anyone tell me how can we reverse the list using this feature? So if we have sample list, tell me what we will put to actually reverse the list. So we see 10, 9, 8, 7, something like this. Okay, I am getting some interesting patterns here. -1 : ::, -1 : ::. Okay, so let's try that. -1 : ::. So what happened? We started at -1, as in the last element, and then we are saying, okay, go to the end, right, with the step size of 1. But there was nothing after that, so you just printed 10. Does that make sense? Because start is always included. You see the close and open interval here. So you put -1 here, so you're pointing to the last element, and then you're saying, okay, go to the end, and then step size of 1. Okay, so I'm receiving -1, 0. Interesting. So are you guys trying those? Because the good thing is that you all can try those indices and try to understand. So here is one good thing. We'll to Vega. If I get your name pronunciation wrong, But we'll work on that later. When you have this list where you don't know what is the order, or like what is the composition in that list, and how can we extract the even element. So here somebody pointed out -1 colon -2, still not working, right? Okay, -1. Perfect. Perfect. So you see what, so now I hope you guys understand the logic behind it, or it's not like just a random thing happening here, you know. -1 is always included, so that's 10, right? And then you were telling that so it already set the stage that start is the we are starting from the end of the list, right? And then you, by default, because you're now going back based on the step size of the -1, it assumes now that, okay, since I started from the whatever position you gave me, and now you're telling me to go back based on this step size, I'll keep going back until I hit the other end. Okay, so other end is naturally this start, right? So basically started from 10 and then going back, and then it hit the end, right? So the other short way, Python has this clever way of not giving users more comfort, is sample list and just say -1. So based on this -1 itself, if you don't say anything on these two positions, it assumes that, oh, since I have to go back, I can't go back from the start. So I will go back because you see there is an order, right? Here. So the index here is 0. So you can't subtract 0 -1 and point to something, because it's always start from 0. So then it basically says, okay, since you gave me to move backwards, I'll start from the end and keep moving backward until I hit the start. Okay. So this is one of the ways you can actually get the reverse of the list, right? Does that make sense? Any questions on indexing? You can put it in the chat box if you have any questions on indexing, and I'll try to address those. Right. Okay. So we practice this the slicing of the list, reversing of the list, and now we will actually explore. I see some question I have not understood. Okay. Sure. So let's do a very simple example. We'll take this particular example, just 2 elements, or let's say the basic element. So, okay. So we have 3 amino acids, arginine, histidine, and lysine, which are basic in nature, right? Okay, sample list. Oh, let me come to that, Dr. Sandeep. Let me just go through one of this example where it's very basic to understand the indexing. So let's say basic amino acids, right? And now let's say I want to access arginine, right? So this particular element. So as I was telling earlier, that Python is 0 based indexing. So if I say basic AA and then say 0, then it'll give me arginine. If I say 1, it'll give me histidine. If I say 2, it'll give me it'll give me lysine, right? If I say basic amino acid -1, then it'll give me lysine, because it's saying that give me the last element. Okay. If I say -2, the second from the last. If I say -3, then third from the last. So third from the last is what? Arginine. But if I say -4, then it will throw me error or list index out of range, because there are nothing 4 from the last, right? Or even if you just say 4, then it will again complain a list index out of range, because there is nothing there, and the length of the list is already only 3, right? Offline on our data. I hope the Jupyter notebook is working, Vanya, on your end. Oh, so you are saying this particular list is something that is foreign to you. Sure, you can, let's say a very simple example. We can just say alphabet, you know, alphabet. Let's say A, C, right? Okay. Yeah, I'll do that. I know. So then here you can say alphabet 0 is A, right? Is everyone able to execute this thing, alphabet? And I'll then go into the even number indexing. Please write yes for this part, alphabet A, B, C, D. Cool. So then this is how indexing works. At 0 you have A, at 1 you have B, at 2 you have C, at 3 you have D, right? And this is how we can actually access. When we say 1, then it's B, right? When we do this, it's C. When it's 3, it's D. But when we say 4, we are supposed to get E, but we didn't actually populate this list. So that is why we didn't we got this error. And errors are actually really useful in terms of if you know the way to kind of understand these. For example, it is exactly saying it is index error. Okay, and it's saying that list index out of range. It clearly tells you that you are using some index which actually it is going out of the bound of the length, right? So when you have this length of 4, then your index are what? 0, 1, 2, 3, right? That's the only index that you can actually use to access the elements. When you go either higher or lower, so for example, when you say -1, -2, -3, -4, -5, then you get this error. Again, it's saying that you have list index out of range, right? When we say -1, we get the D. As I was telling that you have this convenient way of accessing elements in the reverse way also. Just use the -1, right? Then -2, you get C. Is this clear to everyone? Maybe I went a little faster, but I want to revert back a bit, and then because this is really important. Cool. Okay. Then going back to, let's say now we create this numerical list 1 to 10, right? 1 to 10 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Is everyone able to do this? Because okay. Now this is a very nicely formatted list, and we want to practice the way we can actually slice the list, or get information from the list. So what information we are interested in right now is, oh, can we access all the even elements from this from this uh, list, which are actually 2, 4, 6, 8, 10. We know that this is very nicely formatted list, that at position like it's starting with 1 and ending with 10. So we know that we know the positions of the even numbers, that after when you leave one number, then you have the next number which is of the same nature, right? For example, if you start with 1, then you are getting all the odd numbers. 1, skip 2, then 3, which is odd. 4, skip 4, then 5, again odd. Skip 6, then 7, again odd, and then 9, again odd, right? Make sense? Then yes, let's do that. So when now we want to actually access the even numbers, right? So then say 1 to 10, and then what is the definition of the indexing? So you want to say, where do you want to start, where do you want to end, and what is your step size, how frequent you want to actually jump. Okay, so here I want to start, see by nature you are seeing that this list is starting with 1. So we definitely know that if we start at 2, like the second position, which is what, because Python is 0 based index, so our index will start from 1, which will point to 2, right? Because 0 points to 1, right? So 1, and then we want to go to the end, right? So what is our whole length here? If we say 10, then, and then we want to skip always 1, right? So we want to say our step size is 2. So say jump 1 and then get me the next one, right? So then we are getting this 2, 4, 6, 8, 10. Is this clear to everyone? Great, great, great. What is the step size? Yeah, so step size is something that you are saying that I am not interested in, for example, 2, right? So I'm not interested in continuous, I'm interested in every second element. Okay, so if you say 3, then you are interested in every third element. So you see that 2, and then you are not interested in the next 2, but on the third one, right? So then 2, 5, and then again you are not interested in these 2, you want to actually get the 8, right? Does that make sense? Right? So yeah, the very good question. If we want to skip by 4, then we only get like 2, 6, 10, right? So he's not interested in these 3, 6, and then not interested in these 3. I want to get the 10, right? So this is the way you can actually slice the list. And I was explaining other type of indices. For example, this negative number, right? Negative number is always giving you the end. So now somebody wrote on the chat, why not we do this like 1 and then -1 and then 2. So what is happening here? Like this is really important to understand. The step size positive telling you to move forward. Okay, so that's clear. You're starting at 1, which is pointing to 2, right? Then you are saying this end. You see this this particular syntax here, this end is -1, right? So what is -1? Let's forget about this thing and then say, okay, let's open a new shell, and 1 to 10, and let's see what -1 gives me, because it is giving you the last element, right? Right? And by definition, Python indexing is closed and open. What it means is that whenever you write, let's say sample list, or no, 1 to 10, sorry. 1 to 10. When you say 0 to 3, then 0 will be included. Whatever value at the 0 index will be included. Whatever the value at 1 index will be included. Whatever the value at 2 index will be included, but not the one at 3 index. So what numbers we will get? Can anyone tell me on chat? If I say is okay, I'm getting mixed answers. So yeah, Shomesh said you will get 1 to 4. Okay, rest of them are saying 1 to 3, right? So Shomesh, we will not get 4, and I'll explain you why. Okay, because it is based on closed and open intervals. So that's what I'm saying. You will get the value at index 0, you will get the value at index 1, you will get the value at index 2, but then you will not get the value at index 3 because it is open interval. So when you say 0 to 4, you will only get till 4, not 5. Okay, right? If you say 0 to 7, you will only get till this guy, not the 8, right? Because 7 index is pointing at 8, right? Make sense? Okay. Yeah, we'll work on that. This, how can we separate the even numbers from that? That's a little bit advanced right now, Ravi, but we'll get there. Okay, I have that in mind to cover today. But in so far the indexing part is clear. So what was happening here? Let me just go back one more time here. So 1 to 10, and somebody said, okay, why not we use 1, -1, and 2 to get all the even numbers? We didn't get 10. You see, we got the even numbers 2, 4, 6, 8, but we didn't get 10 just because of that region of this open interval. Because when you said -1, then you're saying that do not include that last element. Okay, if you hadn't put anything, then you're telling the list to go all the way through and get me all the elements. That's why you got the 10, right? But when you put -1, you're saying, okay, keep go everywhere, but do not include that last element. So that's why we didn't get the 10. Is that clear? Does that make sense? Whose question was that? Cool. Okay. So you guys can practice on your own also based on the indexing part, and 1 to 10, can we use this? Yes. That's definitely that's what we have been using to get all the even numbers. Oh, okay, sure. So let me explain a little bit of the open interval. So 1 to 10, 0 to 2. So yeah, so this open interval, the fact that you have this, it is the kind of, I would say it's an advantage of Python language that it has maintained this indexing method where your start is always included, but the end is not included. This gives you so much advancement in real life applications. We'll go through that in a later session when we do some advanced sessions. But one question was that why 10 was not coming when -1 was used, right? So again, we go back to this particular example or the syntax. The internal of that is that the 2 colons are actually giving you the space for 3 parameters: start, end, and step size. Remember this, when you when this end, start to end, right? This syntax always include the start index, but not the end, right? Not the end. So that is when you say -1, then you are saying that last end is my last element not to be included. For example, let's practice this way. So when we say length of this list 1 to 10, this is 10, right? So to get all the elements of the list using indexing, so when we say, oh, print 1 to 10, you don't know what index were used, right? But let's now practice this 1 to 10, but I want to actually print this whole thing using the indexing method. So where I want to start, always Python is starting with 0 index, so I'll say 0. Where do I want to end? This length is 10, so if I say 11, what will happen? Tell me. It is giving me till everything. If I say 10, what is happening? I'm getting the whole list. Why? What happened here is that when you start with, when you say 0 to 10, it is starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is actually total 10, right? Because it's starting from 0. It didn't include the number 10. So for example, if you say, I'm giving you one advanced function here right now, but let's say if I say list and range 1 to 5, I just wanna kind of give you kind of a glimpse of how indexing works. See, when I say 1 to 5, 5 was not included, right? 1, 2, 3, 4, right? When I say 1 to 10, you see 1 to 9. So 10 is never included, but 1 was included. Does that make sense? So Harshita is saying, does it mean -1 is last number, but last number is 9, which is not even no. The number in the list is the actual value. The index is the way actually you point to them, right? For example, let me, is there a here I have it actually. So here is the example. You can have anything in the list. For example, let's say we are taking this 2 acidic residues, aspartate and glutamate. You are having this index which are numerical. Although you are seeing the character here in the list, these are the values, but they are located at this index, right? So the numbers in the list are actually the values, right? So don't be confused with that. Oh, the -1 is actual number in the list. No, it is telling you this the index, because you see the order matters. You wanted to tease the kid by saying J is occurring first, then O, and then H, and then N, right? In the list you have this JOHN and then DOE followed by this space, but in the list, how do you access it? Because at 0 J is stored, at 1 O is stored, at 2 H is stored, right? Similarly, when you say -1, it will give you E, because that's the last element in that list. But -1 is what? Is the index, right? That's the way you actually access the list elements, right? So I hope the questions on indexing were cleared. I can put more kind of maybe a couple of more examples in a separate notebook and share it with Praveen, so that he can also put it in that Google Drive or whatever sharing methods that he has. But this is good actually. Indexing is one of the heaviest part in the list, right? And slicing, right? So we actually covered more thoroughly, very thoroughly in those, and I'm actually very happy that various kind of opinion. Yeah, Namrata is saying, can you explain this one, 2, 3, 4, and how? Okay, sure. Let's take your example. 2, 3, 4, 5, 6, 7, 8, 9, 10. I think from Zoom we can't copy. So let's say you have this list A, and then say 2, 4, 3, 5, 8, 8, 7, 6, 9, 10, 10, right? And you want to actually access all, get all the even numbers, even of from A, right? Right. This is going a little bit advanced, but what you can do is even number if number percentage 2 is equal to 0 for num in A. So I think in advanced, if num percentage 2 is equal to 0, right? Yeah. Because I basically stated even this is the right way to actually access. So here you can see you are getting all the even numbers. I wanted to keep it simple in the beginning. Yeah, we'll cover all those how to work if sample numbers are in decimals. Yeah. We'll cover everything. So this is the way to actually get all the right definition of using this num percentage 2 is equal to 0. So what this particular thing is called a list comprehension, right? I wanted to go a little bit later in our kind of session, but people are very much interested in how to actually get the even numbers from there. um, so this is how you actually get it. So this is called list comprehension. Here you can see very kind of a so many things are happening in here only in one line. So you started with A as a list, and then you say even number. Let me put this even number from A. Then you what you are saying is get me the number. You walk through the number using a for loop. We haven't covered that, but people are interested that then I'm just covering it. You walk through all the numbers in the list. So A is your list. So you're saying that for num in A, so walk through each of them and only keep the number if number is completely divided by 2, right? Then this is saying that it's the true definition of the even number is now implemented, and then you are getting the even number from that list, right? Now you can put whatever 101, 90 something, 37 right here, and then you can still run it, and then you get this even numbers from A. Sorry. Then you get the 10 and 90 and 90 here, right? So 101 and 37 are not there, not even, right? So let's say if you want to get the odd number, then you just toggle it to say 1, and then you get all the odd numbers from the list. Does that make sense? How we find the fraction number? Fraction number, I didn't like get it. Can you SP Singh? And there is Shugumar who is saying that how to work if sample numbers are in decimals. Doesn't matter. Like you are saying, to get the even numbers. Sorry, I cannot close that. Having issues in getting that. Oh yeah, here. a fraction or a fractional number. Fraction as in like float number. Maybe you are saying that fraction number as in like 0.5 or something like that. Oh, float number. Okay. Yeah. And then what is your question then? How we find a fraction number? I see. Oh, okay. So here is the thing. Okay. So now people are really interested in going actually a very advanced level. So so let's say you have this fraction number as SP or let's say like list of float numbers. Okay. So here you have 3.7 and then you have 1, you have 55 or 55, and then you have 5.333. Okay, so you have list of I mean a float plus whatever, you can make it float like this, right? Now you actually no, I want to keep some of them as integer, right? Then you want to say so you want to actually get 0.5, 3.7 and 5.333. That's the question, right? If I understand correctly, right? Then again, this is one of the best thing in Python you have to actually operate in the list in one line. Okay, so what will be the logic on extracting all this fractional number and leaving out this integer number? Any kind of hint from anyone? N% 1 is greater than 0. Okay, so let's say somebody is saying 0.5% 1. No, this will not give me. If I, oh, okay, sorry. I kind of, but let's say if we do 5.33, I think it will hold. Yeah, so I was leaning towards the typecasting, but this logic works. Right, so many ways to do it, right? So let's say only float, right? Only float number. So again, we use the list comprehensor, right? FL float for FL in list of float numbers. Actually, the name is wrong. If FL percentage 1 is greater than 0, right? See, you don't. So this is the advantage of Python, and like you want to focus on your research or on your output, and you code it in one line. That's the advantage, right? You can, and like if you turn it to 0 equal to 0, you just get the integer ones, right? I don't know why it put, oh, I see. Okay. When you put one float number, I guess it just converts everything into float. You see this? If you have we didn't touch many things. People are so much interested in but anyway, I do want to since you guys are so tempted in actually exploring the list, I want to kind of skip many details or the jargons here and give you one thing that you can actually explore by yourself. And yes, type the yeah I think it will work. Has it worked? Oh yeah. Sorry. Let me go there. Where is that? Actually, I cleared all that. Okay, so yeah, here, before we kind of conclude, I want to give you a couple of things that you guys can enjoy of the class. Uh, so let's say you have this list of float numbers. You have the list with you, and you are very new to the Python programming, and you ask, oh, what can I do with this list? Like what all this list can do, right? So that's where you say in Python language, it's a kind of a object-oriented programming. If you don't have much background in terms of what this term means, in nutshell, every variable that you define, let's say if you define a is equal to 5, right? So it's an integer, right? But still an object. So if you say a dot, right, then you get all the things actually you can do with that particular variable, right? So for int, these are the things actually you can do, right? So let's say if you say very simple, there is 2 bytes, right? A dot 2 bytes, right? I think you don't need to say this. This is a function. So it will give you, oh no, 2 bytes. Let's say define a string. Actually, that's much better. A is equal to my string, right? Then a dot, you see, capitalize. So here dot gives you access to what all things you can do with that particular variable, right? Sorry, where is that? Sorry, Isaac, maybe I've been, I guess I am fast. I apologize. I'll stick to maybe I'll kind of calibrate my pace, but since I wanted to cover a little bit more on list, I want to leave you guys with something that you can practice on your own. For example, you have this list of float numbers, right? And you want to know what all I can do with the list. Then you said press dot and hit tab. Are you guys able to do this? Let's say you have this list, and then any list, doesn't matter specifically this list. Just type dot and hit tab. And do you see all these kind of menu bar coming up? Can you hit yes or no in the chat box? Cool. No, okay. Prasanna. So can you not press dot and just kind of run this and see if you're seeing anything? Because you need to have that variable defined. There should be something, and then press dot and then tab button. Prashant, are you now able to actually get it? Prashant Saxena? No, not yet. Okay. 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 Let's say you had this 1 to 10 variable. If you still have that in your shell, then just say 1 to 10 and then say dot and then hit tab button. Cool. So now this is actually facilitating you all this kind of a function that you can actually use with this particular list. And let's say you are not aware of what this particular function do, let's say append. So what does this do? I have no idea. So Python gives you this very nice way to actually know what a function do. You just put a question mark, like in our language, you want to know the help of this particular function, then you just say question mark and then run this particular thing. Then something will appear at the bottom, right? So here it says doc string. On the top, you have this signature, this 1 to 10, then append. This is the function. And then you say this doc string, where they kind of abbreviate what this particular function does. Is a append object to the end of the list, right? So we'll just practice this one and then we'll conclude the session for today. So let's say you have 1 to 10, but then now actually something came up and then you have 11 to be included in this list, right? So then you say dot append and you say 11, right? And you run this, then you see 1 to 10 is now 11 is there now, right? Are you guys able to run this append function? Great. So I've just demonstrated one, but you guys can explore the similar function like extend and pop and those kind of functions, which I can cover more. But now, I'll see my pace. Maybe I've gone a little bit too fast today. Oh, yes. Kaushik, yes, you're right. Like whatever the remainder you get after dividing with 2. Yeah. So we'll conclude here today. I'll give Praveen a snippet of some of the examples that I wished to include in today's session. Hope he can include in the Drive link some of the examples. And then we'll definitely move forward with list and dictionaries tomorrow, and looking forward for that.
So thanks.
Over to you, Praveen.
Thanks, Dr. Satya, for wonderful session. And you take a lot of queries, and participants are thanking you for your wonderful session. So Dr. Satya will be again with us tomorrow and day after tomorrow, and then will again Dr. Satya will deliver on our platform. So there are total 10 sessions on Python, and we have only concluded 3 sessions. So thanks. Isaac is saying great presentation, and your
no, I want to apologize to Isaac. I'll give some material to you.
So Isaac is saying index was the trickiest, but
it took the whole session, you know.
Yeah, so doesn't matter, and our aim is to provide best of the content. So thanks, Satya sir, for your time and accepting our request to deliver on our platform. So so there is a kind request. Can you share this your Python file to us so that participant can?
Yeah, I'll do that.
Okay, yeah. So thanks, sir. And I will also share the Python file of 2 sessions of Dr. Avinash with you, most probably today. So I will also share the video recording of this session of Dr. Satya with you as soon as possible, and we will meet again with Dr. Satya tomorrow at the same time. So hope you people are enjoying learning with the Code Life and our worthy instructors. So thanks. And now I will seek permission of Dr. Rao for ending today's session, sir.
Yes, perfect.
Thank you, sir. Thank you.
Yeah.